what we have here is our example number 6 circuit. We've already gone through and found the equivalent resistance to be 2.73 ohms. Now we will go through and find the current and voltage in each resistor. We start at the very last picture when we're doing this. We see that these last two resistors, A and BCDEF, are connected in series with each other. That means they must have the same current. I'll use the information of the voltage from the battery along with the equivalent resistance to calculate that current. And I'll mark that in my diagram here. My battery voltage is 12 volts. So I can calculate the current. 12 divided by 2.73 ohms, or 4.396 amps. Going back to my very last picture here, I'll mark that on my diagram as the current for both. I can then calculate the voltage in each of these. The voltage for the 1.73 ohm resistor is 7.604 volts. And over here we have 4.396 amps. Since that's one of the original resistors, I'll mark that in my chart. Now we know everything we could possibly know about this very last picture. So we'll move up one picture. The difference here is that we have two separate resistors, B, C, D, E, and F, whereas before we had them combined. Because B, C, D, E, and F are in parallel with each other, they have the same voltage as the resistor B, C, D, E, F. In other words, they both have 7.604 volts. I can then calculate the current traveling through each of them. The current through resistor F, which I will mark on the chart here, is 2.535 amps. And its voltage is 7.604. For resistor BCDE, we have a current of 1.873 amps. I now know everything I could possibly know about all the resistors in this picture, so I'm going to move up one. Here, resistors BC and DE were combined in series to get BCDE. Since they are in series, they have the same current, and so each of those two resistors has a current of 1.873 amps. I can then calculate the voltage in each. For resistor DE, my voltage is 5.108 volts. And for resistor BC, my voltage is 2.497 volts. know everything I could possibly know about this, so now I will move up a picture. Here, resistors D and E are separate. They're in parallel with each other, and we combine them to get resistor DE. Because they are in parallel, they have the same voltage as resistor DE, so they both have 5.108 volts. Since they are original resistors, I will put that number in our chart. And now I can calculate the current in each of those. For resistor D, our current is 1.022. And for resistor E, our current is 0.851. We have two resistors left, and those are resistors B and C. We see that those two resistors are in parallel, and were combined together to get resistor BC. Because they are in parallel, they have the same voltage as resistor BC, so 2.497 volts. I can then calculate the current for each of those. For resistor B, my current is 1.249 amps. And for resistor C, my current is 0.624 amps. I've finished my chart, which means I'm finished with the problem. A quick review of what was done here. I started off with my pictures that I drew to find the equivalent resistance. I didn't show this on this video, but if you look at the old video for this problem, you'll see that I lettered each of these resistors and then went through and lettered subsequent resistors showing which resistors were combined. So where I had resistors B and C before, right here, I combined those to get resistor BC, and so I labeled it as BC here. Where I had resistor BC and DE before, I combined that to get resistor BCDE. So that's where all those letters came from. I started at my very final picture when I was trying to find current and voltage. I found the current and voltage for the battery, knowing the equivalent resistance. I then knew that these two were in series, so I could find the current and voltage for each of those. I then moved back a picture. These two resistors are connected in parallel, so they have the same voltage as this resistor that had the equivalent resistance of those two. I could then find the current. I moved up a picture and noticed that BC and DE were in series, so they have the same current as resistor BCDE. I then found their voltages. Moving up a picture, I noticed that D and E here are in parallel, so they have the same voltage as DE. I could then find their currents. And finally, B and C are in parallel, so they have the same voltage as BC. Let me know in class if you have any questions.